Chemistry in everyday life we will take. Okay. In this first we will see about drugs. In this first point we are seeing about the drugs. Drugs we will see. Drugs means which are called drugs in the sense how the molecular mass of drugs will be there. These are chemicals. Drugs means chemicals, and how the molecular mass will be there means low molecular masses. Drugs means chemicals of low molecular masses, and how the molecular mass will be there means 100 to 500 AMU, otherwise unified mass. Then these drugs are doing what? It is interacting with what? That we'll see. It is interacting with macromolecular targets. It is interacting with the macromolecular targets. Macromolecular targets. What is the macromolecular targets in the sense carbohydrate, lipids, then proteins, then nucleic acids, Okay, these are macromolecules. These macromolecular targets are attacked by these drugs. Okay, these drugs are therapeutic. Drugs we can say therapeutic. That means it is curing disease. It is therapeutic means what? Curing disease. So therapeutic means provides a cure from ailment. Okay. Next, we will see about the word called chemotherapy. The word called chemotherapy. Chemotherapy means in this what they will use in the sense they will use drugs for what case in the sense for therapeutic effect. So next we'll see classification of drugs. We'll see about classification of drugs. First classification of drugs based on what? First classification of drugs based on pharmacological effect. Pharmacological effect. First classification of drugs based on pharmacological effect. How they were divided? It provides what? This based on this classification, it is providing what we'll see. It provides this classification provides the list of drugs. The list of drugs for the treatment of a particular type of problem. Treatment of a particular type of problem. Okay, so it provides the list of drugs for treatment of a particular type of problem. That means this is a tablet. This tablet will cure so and so. That list, such a type of list, it will give. So now example we'll take. Suppose analgesic. Analgesic in the sense that is called painkiller. Analgesic in the sense painkiller we can say. Next, antiseptic. Antiseptic in the sense it kill or arrest the growth of microorganism. What is meant by antiseptic means? Antiseptic means it will kill, otherwise it will arrest the growth of microorganism, we can say. Microorganism. Next, classification of drugs based on drug action. Based on drug action, drugs will be classified. Based on the action of drugs will be classified. Here we can say all antihistamines inhibit the action of histamine. Inhibit the action of histamine cell. Next, what is the action of histamine? That we'll see. What is the action of histamine? That point we'll see. Action of histamine. It is a chemical base. Histamine means it is a chemical base. It is a chemical base found in all the organic matter. Found in all the organic matter. This chemical base present in all the organic matter. Then this is a, now we'll see C5H9N3 released in allergic reactions. In allergic reactions. Next, dilates blood vessels. Dilates blood vessels. Blood vessels. Stimulates gastric secretion. Stimulates gastric secretion. Stimulates gastric secretion. Causes contraction of uterus. Causes contraction of uterus. Okay. Next classification we'll see. Next classification based on chemical structure. Based on chemical structure. Next classification based on what in the sense chemical structure we can say. For this, what is the example in the sense sulfonamide? For this example is what in the sense sulfonamide. Sulfonamide. This sulfonamide formula is NH2. This phenyl ring SO2 NHR. SO2 NHR. This is sulfonamide. Okay. Next classification based on molecular targets. Based on molecular targets. Based on molecular targets. Okay. Here we'll see drugs possessing some here based on molecular targets. That point we'll see drugs possessing some common structural features. Some common structural features. Some common structural features may have the same mechanism of action. May have the same mechanism of action. Same mechanism of action on targets. On targets. Set. Next, it is based on molecular targets. We said. Next, catalytic action of enzymes. We will see. Next, we will see catalytic action of enzymes. Next point we are seeing about catalytic action of enzymes. We are seeing. Sorry. Catalytic action of enzymes. Now we will take a enzyme. We will take. Suppose the shape of enzyme is like this. It is the shape of enzyme. In this enzyme, this part is called what in the sense active site. In the enzyme, active site will be there. So, and we will take substrate. We will take substrate. Substrate. The substrate is what in the sense substrate is like this. So, what is the shape of substrate? Like that shape, that substrate should fit in the enzyme active site. Okay, so enzyme will have the shape that this is active site, this is substrate. The substrate which can fit here, that will go for enzymatic reaction. So this substrate fitting in this active site, fitting in this active site. So this substrate going to fit in this active site. Okay, so enzyme holding substrate. enzyme holding substrate. Enzyme holding substrate. Therefore, what will happen means this enzyme making this for a chemical reaction, making this for chemical reaction or biological reaction fast. It will act as a catalyst. Enzyme is acting as a catalyst. Okay, the substrate which can fit in the particular enzyme active site, in that only substrate will go and fit. Then this enzyme will catalyst this for the chemical reaction or biological reaction, we can say. So, next we will see enzyme inhibitors. Next we are seeing enzyme inhibitors. Enzyme inhibitors. In that two types are there. One is called competitive inhibitors. Another one is called sir. In this we will see competitive inhibitors. Competitive inhibitors will take. Competitive inhibitors. Okay, enzyme inhibitors. In that competitive inhibitors we have taken. Sir, in this what is competitive inhibitors? We will see drugs compete with the substrate for their attachment on the active site of enzyme. Such drugs are called competitive inhibitors. Such drugs are called competitive inhibitors, we said. Sir, now we will take enzyme. We have taken enzyme like this. In this enzyme, this is active site. In this enzyme, this is active site. Now we will take the drug. We will take drug and the substrate will take. This is what in the sense a drug. Then this is what in the sense substrate. This is what in the sense substrate. Sir. Now, which is going for a active site of enzyme in the sense drug is going for active site of enzyme than substrate. Drug moves faster than substrate towards enzyme active site. Okay. So drug is moving faster than substrate towards enzyme active site. So to the enzyme active site, which will be there in the sense that drug will be there, but not substrate. Therefore, drugs compete with the substrate for their attachment on the active site of enzyme. Therefore, it is called competitive inhibitors. Sir. Now, drugs binds at allergic site. Drugs binds at allergic site. Drugs binds at allergic site and change the shape of active site and change the shape of active site. Change the shape of active site of enzyme such that substrate cannot recognize the active site of enzyme. So what happens means drug is moving faster than substrate and going to active site of enzyme. This drug, as soon as it goes to active site of enzyme, it changes its active site shape. Therefore, substrate cannot go to this place. Okay. So such a type of inhibitors are called competitive inhibitors. Competitive inhibitors, you can say. Next, receptors as drug targets, that we'll see. Receptors as drug targets, that point we'll see. Now, before that, this point we'll see here. This point will say drugs binds at allergic site and change the shape of active site of enzyme such that substrate cannot recognize the active site of enzyme. This is there. So how this will be there, that point will see. Now we'll take a enzyme like this. This is a enzyme. Okay, in this enzyme, this is active site. It is active site. It is a allosteric state. It is a allosteric site. Now drug is coming here. What it does in the sense, it changes the shape of active site. Changes the shape of active site like this. So what is coming here in the sense, inhibitor is coming here. Inhibitor goes to this place. Inhibitor goes to this place. So active site of enzyme is changed now. Therefore, substrate cannot come to this place. Like this is called enzyme inhibitor, we can say. Next, receptors as drug targets. Receptors as drug targets. Receptors as drug targets. What is a receptor? That we'll see. Receptor is a protein. Receptor protein are embedded in the cell. Are embedded in the cell membrane. In the cell membrane. Receptor protein are embedded in the cell membrane cell. Now we will see regarding that. Now we will take a receptor protein. Will take. We have taken what in the sense receptor protein. This is what in the sense receptor protein. Receptor protein we have taken. Then cell membrane we will consider. This is this inner surface of cell membrane. This inner surface of a cell membrane. Inner surface of cell membrane. Then we will see this is a outer surface of cell membrane. Outer surface of cell membrane, we can say. Outer surface of cell membrane it is. Okay, cell. So cell membrane is present like this. Okay. Next, so receptor protein are embedded in the cell membrane. We said it is a cell membrane. In this cell membrane, receptor protein is embedded. This is what in the sense, this point is what in the sense, a binding site of receptor. Binding site of receptor. Binding site of receptor, we can say. So, in this continuation, we'll see chemical messenger is received at the binding site of receptor. Chemical messenger is received at the binding site of a receptor protein. At the binding site of receptor protein to transfer message to the cell. To transfer message to the cell. To transfer message to the cell. How it will be there, we'll see. Now, receptor protein. This is what means outer part of outer cell membrane. This inner cell membrane. Now, chemical messenger comes to this place. chemical messenger comes to this place. It is chemical messenger. Chemical messenger comes to binding site of receptor protein. This chemical messenger transfers message to this. So message is transferred. Message is transferred now. Message is transferred to the cell. Message is transferred to the cell. Next, receptor proteins. Next, receptor proteins are selective to receive chemical messenger because binding sites have different shape, structure, and amino acid composition. Amino acid composition. Okay, receptor proteins are selective to receive chemical messenger. That means because binding sites have different shape, structure, and amino acid composition. This is the binding site. This binding site shape will be different for different proteins. Therefore, which messenger will have same binding site as like this, that messenger will come here. Okay, sir. Next. Drugs that bind to the receptor site, and inhibit its natural function, and inhibits its natural function are called antagonist. These are useful when blocking of message is required. These are useful when blocking of message is required. These are useful when blocking of message is required. Okay, these are drugs. Sir, so what drugs are doing means drugs are going to receptor site and changes its natural function, means changes its shape. Therefore, it blocks the message. Message will not be transferred. Now, drugs will go here, change this shape. Then how chemical messenger will identify this shape? Cannot. Therefore, chemical messenger will not come. Sir, next point we'll see drugs that bind to the receptor protein as like natural messenger are called agonist. These are useful when there is a lack of natural chemical messenger. When there is a lack of chemical messenger. So drug itself acts as natural messenger. When lack of chemical messenger is there, that time we can use this one. Okay, such a type of drugs are called agonist. So next we will see antacid. Next we will see about antacid. Antacid example is what in the sense of sodium bicarbonate. Sodium bicarbonate is an example for antacid. Excess of this, what will happen? Excess of this, what will happen? For what sake we will take antacid? If a gastric juice, if a gastric trouble is there, that means gastric juice excess will be there. In order to neutralize that excess gastric juice, antacid will be taken. This antacid will give basic medium. It will provide basic medium. Therefore, excess of acid in a gastric trouble patient will be neutralized. Sorry.